recording been started or no? Let me start the recording. Right. Right. So I'm using this transformation. Now, what is the reason to use this transformation? You see, I want, just a minute, okay, just a minute. Yeah. So what is the justification to use this transformation? I have to take this diameter into consideration. So this diameter I'll try to shift over the x-axis or the y-axis. So for that I am taking, you can see from here that W is zeta minus half, and that will shift this diameter to the x-axis. So this is the reason I'm shifting the axis. So what was the original map? The original map was sending xi to xi, eta to minus eta, and zeta to 1 minus zeta. So this was the original mapping. This was the original mapping. So I will again convert this original mapping in terms of UVW. So putting xi as u, eta as v, and zeta as w plus half. Accordingly, things will change. So u will become u, eta will become v will become minus v, and zeta was 1 minus zeta. So w plus half will be 1 minus w plus half. On simplification, we are getting this. We are getting this, and you can clearly see this half and this half can be removed, because I can write here, like I can remove this half and write here 0 0 half, and again here also 0 0 half, and we can remove that. So what I have, u v w is going to u minus v and minus w. And look at this, using matrices, this can be written as like this: 1 into 1 0 0 0 minus 1 0 0 0 minus 1 uvw. You can clearly check that after multiplying you will clearly get this. So what is my transformation? I'm keeping these two fixed. I'm just replacing this by cos 180. This is also cos 180, and you see this is exactly the rotation matrix which I have written here. So what I have got, rotation about the u axis by 180 degree, but due to this transformation it is the rotation about the zeta, that particular diameter. Okay, so this was the remaining thing which I wanted to do. Let's go to problem sheet 2 then. Okay, then I'll clear it out. So problem my screen is visible, right?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so firstly, from the problem sheet 2, I'll be picking up the integral questions, and then I'll go to the remaining questions. So I'll first pick up with number 3. Number 3 was integral over gamma e to the power iz. Okay, I should pick up with number 5 because that is just easy. I'll first pick up the easy ones, okay? Then I'll go to the tougher ones. So I'll pick up 5. 5 is very easy. So integral over gamma sin z by z dz, and where what is gamma? So gamma t is the circle of radius 1 and centered at the origin, and for t belongs to 0 to 2 pi. So you should definitely know, whenever I have gamma t like this, a plus r e to the power it, and t is from 0 to 2 pi. So what is this? Can you tell me? What is this curve? What is this contour?
Circle origin centered at A.
Centered at A and radius r.
R.
Right. So this is how the equation of a circle, a counter circle looks like. So look here. So look at this one. Okay. So this is a circle centered at the origin and radius is 1. So this radius is 1 and this is the origin. So you remember the Cauchy integral formula which sir has already given to you all. It was this integral fz by z minus z0 dz. This is 2 pi I
F of Z.
f of z now. That's fine. So this formula will be very much helpful for us in most of the questions, but remember the conditions. The first condition should be this function fz. This function fz should be analytic in the given inside the contour and even on the contour. First condition. Second condition, this point z0 should lie inside this contour. Okay, so this z0 should be somewhere inside this. Okay, and these are the two conditions. When these two conditions are satisfied, you can easily use this formula. So it is very much clear here. I will take the function to be sin z. Sin z is entire, that is, it is analytic everywhere. So then f is analytic everywhere inside and even on gamma, right? So I'm taking the function this way, and z equals to 0 is a point interior to gamma. Definitely this point z equals to 0, I'm taking this as z0. So this point is interior to this contour. So by the Cauchy integral formula, what I have, integral over gamma fz by z minus z0 dz is same as 2 pi I f of z0. So here z0 I am taking as 0. So that is integral over gamma fz is sin z by z dz is 2 pi I, and putting 0 in the function f, so which is sin 0, and sin 0 is 0, so the value of this integral is 0. Okay, any problem, any confusion, you may ask.
No.
Right. So a simple application of the Cauchy integral formula. So we have an extended version of the Cauchy integral formula, which again sir has already given. So let's go to after this, let's go to number 3. So integral e to the power iz by z square dz, integral over gamma, again gamma is the same curve here. So gamma t is e to the power it, and again for same t, the complete circle 0 to 2. Right. Now the process is similar here, but here you have z square. So we'll use this. We'll use this integral fz by z minus z naught whole to the power n plus 1. So this is, do you remember what is this?
Extended formula of Cauchy integral.
So what is that particular value, do you know? That is 2 pi I
2 pi I upon n factorial.
n factorial, and here it is the nth derivative of the function z0. So again the conditions are same here, just the formula will change because here the power is 1. So if you can remember this formula, you don't even have to remember this one, because if you put n equals to 0 here, this will definitely come. Okay, so this is the extended form of the Cauchy's integral formula, which you get as a corollary. So similarly, so can you tell me what should I take here? F
e raised to the power I.
that is a analytic function, is sure. So this again you write the same justification which I have written here. So then fz, or then f is analytic everywhere inside and on gamma. Even on gamma it is entire everywhere. Okay, and again the same reason, and z equals to 0. This is a point, is a point interior to gamma. Okay, so therefore I will use integral over gamma fz by z minus 0 whole square dz. This by the above formula should come 2 pi I divided by 1 factorial. Look at the power, n plus 1, I will take 1 less power here, and the first derivative of the function at z naught here is 0. If you do not understand how I am using the formula, please ask. So that is, just put the things, gamma fz is e to the power iz divided by z square dz. This is nothing but 2 pi I, and derivative of the function. So what is the derivative of e to the power iz? It is e to the power iz, and for the derivative of iz, which is I, and you have to find the value at z equals to 0. So what is the answer? 2 pi I, and this is you're putting z equals to 0 here. So e to the power 0 is 1. So I'll simply remain with I. That is 2 pi I square, which is nothing but minus 2 pi. Right? This is the answer to your required problem number 3. So similarly, you have 6 exactly in the same manner. I'll really quickly do it exactly same. So 6, this sine z by z cube dz. Again the curve is same, e to the power it t in 0 to 2 pi. So not write much justification here. I'll simply write, can you tell me what is this? This integral is 2 pi I by
2 factorial.
2 factorial.
factorial f double prime at 0.
Sin z itself minus sin z.
So here I should write that, I should at least write the justification where fz is nothing but sin z. You have to give proper justification. Okay, you have to write all those things which I have written here, but for the timing I'm skipping it. Okay, so this is nothing but pi I. So 2 times derivative of sine will be minus sine, right? Because the first term
Minus
difference,
sin.
right? So minus cos z, again you differentiate. So
0.
z and then minus sine z, right? So minus sine 0. So again your answer will be 0. Right. Then we have number 4, and 4 is a nice question. Let me properly write the question. Just give me a minute. Calculate the value of this integral 1 by z minus 1 dz, where gamma t is a circle centered at A and radius 1. Okay, for different values of A, such that this condition has been given that it does not lie on this circle basically. Yeah. So here you have to take different values of A and then determine the value of the integral. So this A is not fixed. So you have to, for different values of A is a complex number. Remember that A is a complex number. So you have to choose different complex number A and determine what will be the value of this integral. So any idea from your side, any approach?
Yes, sir.
Yeah, please tell me.
Mod of a minus 1 is greater than 1, then the function is analytic.
Right.
Then the integral will be 0.
Correct, exactly.
And then if mod of mod of a minus 1 is less than 1, then the Cauchy integral formula will be applied. Then 2 pi I will be answer.
Very good, very good. That exactly correct. So what I'll do, sorry, I'll take different values of it. So case 1, so when I am taking when this A satisfies this relation, okay, when A satisfies this relation, that means, okay, this is not equals to 1, that is given in the question. So either this is less than 1 or this is more than 1. So we have two cases for the time being. So we will do the cases one by one. For the first case and for the second case we have this thing, okay. So first case, when this happens. So what I'll do, let fz equals to 1. Now note this, the curve is this, I don't know, the radius is a, sorry, the radius is 1 and the center of the circle is a. This is the contour. Whatever this circle be, my point is that in this case 1 will be inside this circle always. 1 will be inside this circle always. What is the justification for that? Can anybody justify why will 1 always be inside this circle when this case happens? This curve is nothing but what? This can be written
Circle
like this.
centered at a, circle centered at minus a, sorry.
This curve is nothing but this thing which I have written here, right? This is a circle centered at a and radius 1, and I want to know that whether 1 is inside this circle or not. So just put z equals to 1. So 1 minus a, and by the given condition this is less than 1. So that means the point 1 lies interior to this circle. So is my justification clear?
Yes.
So we can apply the Cauchy integral formula because this point 1 lies interior to the contour, okay. So then f is analytic everywhere inside and on gamma, okay. So and z equals to 1 lies interior to gamma. So what is the justification for this? As modulus of 1 minus a is less than, okay. So therefore by the Cauchy's integral formula, fz by z minus 1 dz in excuse me, integral over gamma is 2 pi I f of at which point?
1.
1. So that is fz is 1, z minus 1 dz will be nothing but 2 pi I. What is f of 1?
1.
1. So this is for the first case, okay. And for the second case, so case 2, when a minus 1, this modulus is more than 1, so then no need to take any function. Then z equals to 1 lies exterior to gamma as modulus of a 1 minus a is more than 1. So again remember the same thing, this is my circle, okay, and I want to check whether the point z equals to 1 lies inside of this circle or outside of this circle. So determine this modulus value. If this is more than 1, it lies outside. If it is less than 1, then it lies inside. According to the given condition, this is same as a minus 1 and this is nothing but more than 1. So the point z equals to 1 lies exterior to this circle. So therefore fz, or I'll write simply gz, which is 1 by z minus 1, is analytic at all points interior to and on right, and on basically. So the only point where this was not analytic was z equals to 1, and everywhere else it is analytic, because the derivative, what will be the derivative? Derivative will be minus 1 by z minus 1 whole square.
Z minus 1 brackets.
Right. This exists everywhere except at z equals to 1, but z equals to 1 is not inside of the circle, so there is nothing to worry about, right? So what can I say? Therefore by the Cauchy's theorem, integral of gz over gamma must be 0, and that is integral gz is nothing but 1 by z minus 1 dz is actually 0. This is answer to the second case. So they covered all values of a for which the given integral, okay, so these are the all possible values that a can take, and this has been covered. If you have a question, you may ask. I hope others 3 have done, 3, 4, 5, 6 is done. Okay. Right. Now we have number 7. I can write down the question.
This one is misprint, I think.
Sorry.
Question number 7 is misprint, I guess.
No, it's correct. It is from the book only.
Actually sir, mn inequality से अगर इसको solve करते हैं तो जो इंटीग्रल का वैल्यू है वो लेस देन 7 आएगा, मतलब कि 2 पाई आएगा.
हाँ, but that is a upper bound, मतलब 7 नहीं, तुमने क्या बोला, वापस बोलो.
अगर mn इक्वलिटी से अगर देखें इसको तो ये इसका जो अपर बाउंड है वो 2 पाई आएगा. बट
हाँ, so तुम बोलना चाह रहे हो this integral f this is lesser equals to 2 pi, right?
या सर.
हाँ, but जो 4 है वो डेफिनेटली 2 pi से कम है.
या सर.
हाँ, तो क्वेश्चन में बोला है तुमको इसको 4 से भी छोटा दिखाना. तो हाँ, यहाँ पे ml इनइक्वालिटी अप्लाई नहीं होगा. पहले मैंने भी सोचा था ml इक्वालिटी से होगा, बट यहाँ पे कुछ और तरीका लगाना पड़ेगा. ओके ओके. सो नंबर 7, व्हाट इज गिवन इन द क्वेश्चन? लेट f be a continuous real valued function. So this will be very much helpful for us. मतलब f is a function from some domain of C, but the answer is always a real number. Okay, this will be useful after some time. Remember, it is a real valued function on, so the domain is this, and this domain is, this is a subset of C, okay, such that mod f is bounded above by 1, that is, okay, is lesser equals to 1, bounded above by 1, that is f of z, modulus of f of z is lesser equals to 1 for every z inside this ball. Okay, show that this integral over gamma is lesser or equals to 4, where gamma is again the circle, gamma t is the unit disk basically, this for t in 0 to 2 pi. So obviously the first thing that will think to apply here is the what is said the Mn inequality, but with that we are getting upper bound, but that is not 4. Okay, so we'll try in a different process. So basically you see, I want to find the value of this integral. I want to find the value of this integral. So let's start by finding this. Okay, so solution I want to find. So let fz dz. So I want to find. So इसका जो आंसर होगा that will be a complex number. जो इंटीग्रल का आंसर होगा that will be a complex number. Assume that complex number in the polar form r e to the power I theta. I am taking this integral और इस इंटीग्रल का जो भी आंसर आएगा over gamma, I am calling that as a complex number and suppose in the polar form. Okay. Then what is r? R is modulus of this complex number. Right, r is modulus of this complex number, and not only that, r is again same as e to the power minus I theta integral over gamma fz dz. So ये r क्या वैल्यू निकला, because this I'm considering this complex number, इसका मॉडुलस है r, and ये r का वैल्यू कहाँ से आया, ये r का वैल्यू आया from here, that r will be this shift to the left hand side, you'll get it, right? So both this will be helpful for us. So you see, now according to the question, I want to just prove that r is less or equals to 4. Now my target is to prove that r is less or equals to 4 due to this one, because the value of r is this quantity. If I can prove that r is less or equals to 4, then this quantity will also be less or equals to 4. So that is my aim, to prove that r is less or equals to 4. So the use of this part is at the end now, that if I can prove that r is less or equals to 4, that will automatically imply this part is also less or equals to 4. So I'll use this value of r. So taking r equals to e to the power minus I theta, I can also take that inside the integral, doesn't matter, fz dz. Okay, so r is nothing but integral over mod z equals to 1. This is a circle given, e to the power minus I theta fz dz. So apply the definition of integral. What is integral over gamma fz dz? This is integral
f of t,
f of this
t
t and d. I'll use this result. Okay, I'll use this result here. So what will be this here? Integral over 0 to 2 pi e to the power minus I theta remain as it is, f of gamma t is e to the power it for the derivative of e to the power it. Okay, for the derivative of e to the power it is e to the power it times I dt. Is it correct? Please check once.
Yes, correct.
So you can just write this as 0 to 2 pi. This is I f of e to the power it times e to the power I t minus theta dt. Remember, theta is fixed. Theta is a fixed angle. So let gt is equal to f of e to the power it. Then this is a real valued function of t. It is obvious why it is real value, because f is real value. Whatever you put inside f, you will get a real number. Okay, so this what I have, this is 0 to 2 pi I gt e to the power I t minus theta dt. This is the value of R, right? This implies R equals to, please compute this. This is by the, so by the Euler's formula, this is cos t minus theta plus I sine t minus theta. So gt, so this will become what? I cos t minus theta dt plus 0 to 2 pi, I square is minus 1, I square is minus 1, I'll shift that with sine, okay, so this will become sine of theta minus t. Do you agree?
Yes, sir.
So basically this I and this I are becoming I square is minus 1, so there will be a minus outside, but what is minus sine theta? It is sine of minus theta, so I'm taking that minus inside. So remember, this is why it is important. We have a real valued function. So this is the real valued, this is real valued. So this whole integral is a real number. This is real value, this is real value, this whole integral is a real number. So I have real number plus I times of another real number. So the right hand side is a complex number in the form a plus ib, and the left hand side is also a complex number of the form r plus 0i. So just equating the real part and the imaginary part. So therefore r will be equal to the real part of this, which is 0 to 2 pi gt sine theta minus t dt. And this part will be 0. I am not interested in that part for the time being. Am I clear with this justification? Why is r this?
Yes, sir. Yes, sir.
All right. Now, this is less or equals to, so I should write here less or equals to, so this is again a result that you have done in the class, the modulus. So 0 to 2 pi modulus of gt I hope you will follow this, right? Is it true?
Yes, sir.
And then split the modulus in the next line, so which is 0 to 2 pi modulus of gt sine of theta minus t modulus dt. And you see here, now we'll use this condition which I have not used till now. F is bounded above by 1. F is bounded above by 1, that is modulus of fz is lesser or equals to 1. So this one, so modulus of gt will also be lesser or equals to 1, right? Because modulus, if I'm taking a modulus here, I have to take a modulus here also, that is lesser or equals to 1. So I'll use this fact now. So this is again lesser or equals to 0 to 2 pi, so this becomes 1. So modulus of sine theta minus t dt. So what is the reason? Since modulus of gt is lesser or equals to 1, and this integral is same as finding this integral, because if you change the variables, you'll get from theta to 2 pi minus theta, which is same as finding this. You can check this. This is very easy. If you change the variable, if you put, suppose s equals to theta minus t, if you're putting s equals to theta minus 2, and you can just do the changes, you'll get the limits from theta to 2 pi minus theta, which is same as this integral. You can just check that. Now, what is the value of this integral? You have done this in your class 12th level. You remember how to solve this integral?
Yes, sir.
Yes, sir.
You'll break whenever
So
sine is
4.
right. This will be 4. This is up to you. It's very simple. Okay, you'll break from 0 to pi, and from pi to 2 pi. 0 to pi में sine होगा positive, so you can remove the mod. Pi to 2 pi में sine is negative. You have to take minus sine 10. You can evaluate that limit. You'll get this 4. Okay. So what I have got, r is lesser or equals to 4, and from here this is nothing but r. So this is also lesser or equals to 4. So therefore r, which is nothing but integral, you can also write, okay, fz dz, this is lesser or equals to, right. Any problem, any confusions?
No. No, sir.
Now, so we're remaining with question 1 and 2 from this sheet sheet. Sorry. Yes. So now I'll go to number 2. So number 2, I'll not complete the whole thing. I'll just start with the first part. So what was number 2? Let me write the question very quickly, not the full question. So let f from d to c be a branch of logarithm. Okay, what is the meaning of this?
E to the power fz equals to z.
Correct. So here the domain may be
And
different.
f is continuous.
Right, f is continuous, f is analytic, but f is nothing but the log function. Keep that in mind. F is nothing but the log function, but the branch may be different. Okay, you know the log is a multi-valued function, but here we are restricting it to some branch, so there it will be continuous and single valued first of all. So what I have is, then what I have is e to the power fz will be
Z.
z, right? Okay, then show that for any integer n, so to prove, so z to the power n is e to the power n fz. This thing we know for real numbers. We have to prove this for complex numbers, right? We know that e to the power, we've done this in class 12 also. We use this result in integration and so on. Okay, we want to prove this. Just a minute, okay? Right. So let's take the case y. So I want to prove this for different values of n. So case 1, assume n is more than 0. Then e to the power, I'll start with e to the power n fz. Okay, so this is what, e to the power fz plus fz plus fz n times. This makes sense because n is positive, right? N is 5, so e to the power 5 fz means adding fz 5 times on the power of e. So this is nothing but by the basic property of e to the power fz, e to the power fz, e to the power fz n times. So this is nothing but each one of them is z. So z, z, z n times. So this is nothing but z to the power n. So this has been proved. This has been proved for n when n is more than 0. Any problem?
No, sir.
Okay. Case 2, when n is negative. So assume n is negative. So let n be minus of some positive number for some m which is more than 0. Okay. So then e to the power n fz is same as writing e to the power minus m fz. This is 1 by e to the power m fz, right?
Yes, sir.
And this is 1 by the case 1, because m is positive, I can use case 1. So e to the power m, this will be z to the power m. So this line is by case 1. Okay. And this is nothing but z to the power minus m, and this is nothing but z to the power m. So again, case 2 also has been proved, and case 3, n is 0. So assume n is 0. So this is very obvious. N is 0. Now e to the power n fz is what? E to the power 0, which is nothing but 1, and this is nothing but z to the power 0, which is nothing but z, right? So z to the power n. This has also been right.
Yes.
So therefore e to the power n fz is z to the power n for all n in z. Okay. There was also a second part to this question. This I will not do it today. You can try, you can use your own ideas, but I'm not prepared to do this question. So I'm leaving question number 1 and the second part of 2 for the timing. If I I'll try to solve it. If I can get, I'll send you the solution, or I'll discuss in the next tutorial class. Okay. Okay. And then some of you had sent me some questions to clear, so that I'll pick up now. Okay. So just a minute. Who had sent me? I cannot cover all the questions, but I have picked a few questions. This was sent by so I'll just Sushil had sent me this question. Find the radius of convergence of summation. This is again from the Conway book, I guess. This n x to the power n plus 1. You have to find the radius of convergence of this power series. Okay. So this I have previously done. So note here, one thing to note here. So here, what is an? So let the power series be summation an x to the power n. So what is an? Can anybody tell me? An is
minus 1 to the power
minus
n upon
n by n.
no. For this power, that is an. For other powers, it is always 0. If you take different, if you try to write this power series, put n equals to 0. When you're writing n equals to 0, or you cannot put 0 here, it will be undefined at 0. I should write here, right. So put n equals to 1. Put n equals to 1, you will get what? Minus 1 x to the power, how much? 2, right?
2.
Put n equals to 2 here.
Yes.
You'll get here plus 1 by 2 and x to the power 6. So look here, the coefficient of x cube, x to the power 4, x to the power 5 are all 0. So you cannot say that an is always minus 1 to the power n by n. So keep that in mind. Okay, this is not an what you are thinking. So an is basically minus 1 power k by k if n is a number of the form k into k plus 1. Otherwise, it is 0. Is this line clear?
Yes, sir.
Right. So therefore, to find the radius of convergence, you have to take this into consideration. So lim sup, excuse me, modulus an whole to the power 1 by n. So because the other terms are 0, they will not contribute anything to the supremum. So supremum will definitely come from the remaining terms, this only. Let me change the limit here. As n tends to infinity, k will also tend to infinity. Right, whole to the power 1 by k plus 1. Okay, just a bit simplification. So 1 by k whole to the power 1 by k plus 1. This limit is 1. Why? So I'll use the Sandwich theorem to get it. Get it easy. So why this limit is 1? We can use the Sandwich theorem to get the proof why this is 1, or the squeeze theorem. You often call it squeeze theorem. So why? Because the reason is this. You can clearly see that 1 by k whole to the power 1 by k plus 1 is less or equals to
1 by k की power 1 by k.
right, 1 by k to the power 1 by k, and this is always bounded above by 1. Right, this will be bounded above by 1, I guess. Possibly, we just check once, okay, and therefore this limit will go to 1, because this is going to 1, this this goes to 1, so this will also go to 1 possibly. So check once, okay, it is not that difficult to check. Right, this will be no. This will be bounded above by 1, and the lower limit to this will be 1 by k whole to the power 1 by k possibly. Okay, check this, okay, please check this and verify. It is easy, just this part is very obvious, but this part you just calculate and check once. Okay, so this will be 1. So what can I say, that the radius of convergence is 1. Okay, so just for this kind of question, please carefully choose AN. Okay, and then another question. So this was almost time also. I don't know. Just a minute. I'll just check once. I've done a question. I'll quickly discuss 2 more questions. This is from Joseph Buck only. This exercise, chapter 4. Number 11. The question was, F is analytic in a convex region D, and this derivative is bounded by 1, okay, throughout D. Okay, so what is the next part? Prove that F is a contraction. That is, what is the meaning of a contraction? Excuse me. That is, modulus of FB minus FA is less or equals to B minus A for all A comma B in the domain, or I should also write here A. एक ही बात है, doesn't matter. I'll write here A and so this question has only got one trick. If you can crack that trick, it's done. Nothing is difficult here. This is the first line you have to think of it. Suppose this happens, I'll start from the left hand side. I will start from this. Okay, I'll start from this. So this is only the first line is tricky. Integration from 0 to 1 d dt of f 1 minus t a plus t b dt. Now see, there is a logic behind this line. Because f is analytic, we can differentiate the function d dt. So here I have just written d dt of f, but here I have taken a point 1 minus t times a plus t times b, and this point will also belong to d or not. That is justified by this fact. D is a convex set, right? So this will also belong to D. So, and you see this, what is the integration of this? So dt, so this is just the integration from 0 to 1. Only this thing will remain.
F minus M.
Right, f of 1 minus t a plus t b at 0 and 1. At 1, it will be b,
F of B.
right, and at 0, it will be a,
F of B.
and hence we are done. Right. So only this line you have to remember sort of, because otherwise you cannot do this sum. Okay, and rest is very simple. So now start the very simple calculation. So this is ddt. This modulus will go inside, right? So f of, so this, that is the reason for lesser equals to. So 0 to 1. If I differentiate this, so this is f dashed and use the chain rule. So further derivative will come how much? B minus a, right? So further derivative will come B minus a, right? B minus a and dt. So this is equals to 0 to 1, or I'll jump a step. Lesser equals to 0 to 1 because the derivative is bounded by 1. The derivative is bounded by 1. So what can I say? So this will become 1, and this will remain with modulus of b minus a dt. And because b minus a is a constant, so this will be b minus a, and so 0 to 1, which is 1 minus 0, and this is nothing but a minus b, modulus of a minus b. So this, hence we are done. So we have used all the information in the question. D is a convex set, f is analytic, derivative is bounded by 1. So using all this information, we are done. And I'll just take one more question from Conway, again asked by some student. I'll very quickly do this sum. I could not cover some of your doubts in the next class, so maybe I'll send you the solutions later on. This was from Conway. I don't know which, this is chapter 3 possibly. Conway. This is number 15 of Conway. For r more than 0, let a be this set omega such that omega is e to the power 1 by z, exp 1 by z, where 0 less than mod z less than r. The question is, determine the set A. That means you have to just write down what will be set A. You can say in the roster form, not in this form. Okay. So you see here that this set A is nothing but the image, like, what should I write here? This is from D, and D is this set. This is the set F. This is the set F, right? So you have to find A is nothing but image of whole of this set under F. Do you agree with this justification for the timing?
Yes, sir.
Yes, sir.
Right. So this is the justification that A is nothing but image of the whole of the domain under the function F. So this is a particular justification. I'll just shift this sort of here. Okay. So let me start the solution. So I will do some manipulations. Define S like this. So instead of taking D, I'm writing here S. Okay. Anyways, let it be D only. Define the set D like this. Z 0 less than mod Z less than R. Okay. So the image of, so first what I am doing, instead of doing this directly, this is the composition of two functions, the exponential function and 1 by z. You see, this is nothing but the exponential function composition with 1 by z. Do you agree?
Yes, sir.
Right. I'm first taking, so this is the composition of these two. Remember that. Okay. Okay. I should write here like S at the point z. Right. So I'll first use this function, and then I'll use the function a to the power z. Okay. So the image of, remember, my aim is to find the image of D under the function e to the power 1 by z. But I am not doing it directly. I'll go step by step. I'll first find the image under this, and then image under e to the power z. So the image of this set under 1 by z is clearly T, which is nothing but all those z such that modulus of z is more than 1 by r. So this is very easy. So when you pick up a point z from D, so that implies modulus of z is less than r, and definitely, so the image of z is 1 by z. So when 1 by z, so what will happen to the modulus of 1 by z? So this is 1 by modulus z, and this will become greater than 1 by r, right?
Yes, sir.
If I'm going too fast, please tell me. I'll slow up my speed. After the time is over, I'll try to complete this question. Okay, so I have calculated the image of D over the function 1 by z, under the function 1 by z. Okay, so what is my next step? Can you tell me? This is same as finding
Find
what?
image of composition.
Image of
T.
Composition.
right.
T.
So now to determine A, it is, or A is nothing but image of t under the function e to the power z. Do you agree?
Yes, sir.
Right. So this is our last part. So my claim is that a is nothing but whole complex number minus 0. That is what is my claim? That is image of t under f under e to the power z is whole c minus 0. So this is my claim, and this is the final claim, but it requires some time to prove it. Should I complete it or should I leave it for the time being?
So completed.
Okay, I'll complete it then. I hope you'll give me more 5 to 10 minutes. So this is the last part to show that image of t under e to the power z is c minus 0. Okay. So how can I prove this? How can I prove this particular line? So how can I prove this particular line? Given any non-zero complex number, I will find an element in T whose image under e to the power z is that complex number. So I'll just write that very quickly. So that is to show
Pre-image.
given any non-zero omega in C, that means this, given any omega here, right, there exists z in T such that e to the power z is nothing but omega.
Omega.
Right. So I have to find the existence of such z in T. How to find the existence? Write W is equals to modulus W e to the power I theta and Z equals to x plus IY, right? So, or I should write we have to find Z equals to x plus IY such that, so when will this Z belong to T? When its modulus is more than 1 by R. So such that x square plus y square, the root over, is more than 1 by R. I have to find such a complex number Z. Okay. And Z should also satisfy this equation which I have written, e to the power Z equals to, and e to the power Z must be equal to omega. Am I clear with this justification? I have to find such a complex number Z which satisfies this and this. So this implies e to the power x must be this, and this implies y should be some multi to this one. From here, what can I say? The value of x is, these are all real numbers, so this will be true. And my point is that, and choose, so k is an integer. We can choose k to be sufficiently large. So choose k sufficiently large such that modulus of, so you see, modulus of x square plus y square, right? I want this to be more than that. So x square is log this whole square plus y square. Y is theta plus 2k pi whole square is more than 1 by r. So what I am training is that you can choose k sufficiently large such that this equation will be satisfied. You can actually get the value of k after simplifying this. You are squaring both sides, take k on the left and everything on the right, and you can get k that way. So I can choose such a k so such that this satisfies, this relation satisfies. Thus such a z exists in T. Therefore this set A is nothing but all complex numbers except 0. The whole complex plane punctured at 0. Okay. So this much for today. I'll clear some more doubts in the next class, or I'll send you the solutions to the doubts. Thank you for joining the class.
Sir,
Yes.
sir, sir, Z, the T doesn't contain Z equals to 0.
Right,
So,
right, right.
so, so e to power 0 will we get 1. 1 will not be there in A.
In one will be there in A.
In image 1.
No.
Since so 0 is not there in D dash, that T.
Okay, no. Only e to the power 0 is 1. There are many values. You are in complex plane now. Think that.
Okay, sir.
See, e to the power 2. Yeah, e to the power 2 pi I is also 1, I guess, right? Because this is
Yes,
what
yes, sir,
cos
yes, sir.
2 pi
Yes, sir.
I sine 2
Yeah,
pi. Yeah, so this is also 1,
yes,
right?
sir. Okay, sir. Okay. Yes, sir.
Anything else?
Question 1 का approach क्या होगा?
Yes, Abhishek.
The question 1 का approach था. Problem sheet 2 question.
I cannot hear you, Abhishek.
Question 1 approach, sir.
The question
Problem
1
sheet.
का approach क्या होगा?
अच्छा, अभी तक मैंने उतना टाइम नहीं दे पाया क्वेश्चन 1 को. ओके, सो मैं जल्दी